You've probably heard of the toughest creatures on Earth. But what if I told you there's a tiny animal that can survive being frozen for 1,000 years? This isn't just any animal. It's a creature so resilient that it can endure the vacuum of space, extreme heat, and even the crushing pressure of the deep sea. Its secret lies in a unique protein that protects its cells from damage, and a sugar-based substance that prevents ice from forming inside its body. These tiny survivors are found in some of the most extreme places on Earth, from mountaintops to Antarctic ice, and even in the soil of the International Space Station. What's even more fascinating is that scientists are studying them not just for their survival skills, but for potential applications in medicine and space exploration. Tardigrades are microscopic animals, about 1 millimeter long, with a tough, segmented body and 8 legs. They look like tiny, plump little animals, almost like tiny bears. They're found in all sorts of places: rocks, soil, even the ocean. But they thrive in the most extreme environments, like deserts, mountaintops, and even the frozen Antarctic. When they're in a tough spot, they can enter a special state called cryptobiosis, where they basically shut down their metabolism and become super resistant to damage. This state lets them survive extreme temperatures, radiation, and even the vacuum of space. As long as they're rehydrated, they can bounce back to life. But what really makes them unique is their ability to protect their cells from damage, using unique proteins and sugars that act like a shield against harsh conditions. Tardigrades aren't just fascinating. They're a key to understanding life's resilience. Their survival methods can unlock new ways to protect human cells in space or during medical treatments. Imagine your cells surviving the vacuum of space, or a hospital storing organs without refrigeration. Tardigrades show us how to do this, and it could revolutionize biotechnology. They've inspired scientists to develop new materials that mimic their protective proteins, which could lead to stronger, more durable medical devices and even space habitats. By studying these tiny survivors, we're not just learning about them. We're learning how to survive in extreme conditions ourselves. The future of human survival might depend on it. So next time you see a moss patch, remember, it might be hiding some of the most extraordinary life on Earth, and it could hold the key to our own survival. Tardigrades have been around for over 500 million years, surviving through mass extinctions and changing climates. They've outlasted the dinosaurs and even the Cambrian explosion. During the Permian-Triassic extinction, when 90% of marine life died, tardigrades found refuge in the ocean's hidden crevices. They adapted to extreme pressure and darkness. They even weathered the Cretaceous-Paleogene impact, surviving the asteroid strike that wiped out the dinosaurs. Their resilience has made them one of the oldest living organisms on Earth. Throughout their history, tardigrades have adapted to a wide range of environments, from polar ice to hot springs. Their survival is a testament to their evolutionary flexibility. By studying their ancient history, we can better understand their survival mechanisms. The secrets of their resilience may even offer insights into how life can endure in extreme conditions beyond Earth. Tardigrades are like tiny water bears. They live in the dirt and can survive almost anything. When there's no water, they dry up and turn into a little ball called a tun. It's like hibernation, but for water bears. Even if they're dry, they're not dead. They just wait until there's water again, and then they come back to life. They can even survive freezing, radiation, and even the vacuum of space. That's a lot of tough stuff. So, even though they're tiny, they're super strong and super tough. Like a superhero in a tiny body. Tardigrades live in harsh, unpredictable environments where water is scarce and temperatures can swing wildly. They're often found in moss, lichen, or soil, waiting for the right moment to act. When their environment becomes too dry or extreme, they begin to prepare for a long, dormant state. This is their survival strategy, a way to endure until conditions improve. They start by entering a state of dehydration, which triggers a series of biological changes. Their body shrinks, and they begin to produce protective proteins and sugars to shield their cells. As they lose water, their metabolism slows to nearly a halt, and they begin to curl into a ball, a compact and resilient form that protects them from damage. This transformation is gradual, and each step is a carefully orchestrated response to environmental stress. They're not just surviving, they're adapting. Once the tardigrade is dehydrated, its proteins fold into a special glass-like state called vitrification. This prevents the molecules from moving and breaking down, like ice frozen in time. This glassy state stops all biological activity, halting metabolic processes and protecting the cell from damage. It's like the cell is in a state of suspended animation. Special sugars, like trehalose, help stabilize the proteins during dehydration. They act like a shield, keeping the cell's contents from collapsing or forming harmful crystals. This process is so efficient that tardigrades can survive extreme temperatures, radiation, and even the vacuum of space. Their survival is a masterclass in molecular resilience. Once the desiccation process begins, the tardigrade cells shrink and the proteins inside undergo a structural change. These proteins act like a shield, protecting the delicate molecules from damage. This unique protein structure is what allows them to survive extreme dryness. It's like the tardigrade has built a tiny invisible shelter inside its own body. Trehalose acts like a molecular glue, holding everything in place and stopping the formation of harmful ice crystals that could destroy the cell. Together, these proteins and sugars create a kind of dormant state, where the tardigrade is essentially suspended in time, waiting for the right conditions to return. At the core of their survival is a process called cryptobiosis, where tardigrades enter a state of suspended animation. This is not just dormancy, it's a biochemical shutdown that halts all metabolic activity. During cryptobiosis, they produce a unique sugar called trehalose, which replaces water in their cells and prevents them from breaking down. This sugar acts like a glass-like coating, shielding their proteins and membranes. These proteins are unique to tardigrades and can withstand temperatures from near absolute zero to over 150 degrees Celsius. They act as a kind of cellular armor, preventing damage from dehydration or radiation. Recent studies suggest that their resilience might also involve a form of DNA repair that allows them to recover from radiation damage. This could explain how they survive exposure to the vacuum of space. The science behind their survival is a blend of chemistry, biology, and adaptation. Each discovery brings us closer to understanding the limits of life and how it can endure the harshest conditions. Imagine a tiny, indestructible creature that could survive a nuclear blast, a vacuum of space, or boiling heat. And it's not a robot, it's a water bear. These microscopic animals are like the universe's most stubborn survivors, capable of withstanding conditions that would annihilate most other life. Their survival isn't just about toughness. It's about adaptability, a kind of biological time travel that lets them pause life and restart it when the world is safe again. So, in a way, they're like the universe's most unassuming superhero. No cape, no powers, just a few clever tricks that make them one of the most fascinating creatures on Earth. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.